Hello everyone, my name is Chris Campion and I am presenting my final project on Google BigQuery platform for data analytics. So diving right in, what is Google BigQuery? And it's essentially a RESTful web service that simplifies the challenging task of analyzing incredibly large data sets through high-speed SQL queries. It is an enterprise data warehouse that is accessible through web user interface, command line, third-party tools, or even by making REST calls to the BigQuery API. And I mentioned, of course, it is an enterprise data warehouse because it can scale to that size, but it can also be used by individual users like myself for this project. So why BigQuery? Why would anyone want to use it? The first point that I put on here was how easy it is for technical and non-technical clients to use this tool. You're essentially able to create an account in Google and have access to public databases or upload your own data, and you don't have to have any knowledge about disks or virtual machines or how to architect and set up indexes. You don't need any of that. And BigQuery was also developed partially in response to some of the drawbacks that it saw from MapReduce, which is less than ideal to query large distributed data sets in real time. And BigQuery allows users to enable legacy SQL for rapid interaction between all users and their data sets. Essentially, that legacy SQL is fairly straightforward, and many users can use that. So how does it all work? Three major parts here that I'm going to mention. I could probably spend a lot of time talking about this. This is quite complicated. But at a high level, you're looking at an execution engine, which is called Dremel. And this essentially just breaks your query into pieces, and then it will assemble all of the results. So it turns query basically into an execution tree. And then there's the distributed storage known as Colossus, which uses a columnar storage format and compression algorithm to optimally store data. The network is called Jupyter, which allows users to read terabytes of data in seconds directly from storage. So in practice for BigQuery, this is a typical workplace flow where you have your corporate data, third-party data, which feeds into the cloud, into the Google Cloud. And BigQuery is essentially able then to distribute it out to all of these other apps or tools. So again, you can either stream data into it, or you can bulk upload, and then you can feed it to end users. So as I mentioned, getting started with BigQuery is really simple, and creating an account is just a matter of going to the right website, which is provided here. And you can tag it to your existing Google account. I'm sure most of us have a Gmail account of some sort. So you can link it right to that. You got to create a project, and you have to enable billing. And then you'll eventually get a project ID, like I have one here, Big Data Analytics, and some numbers. Just keep note of that because you're going to need that later. As for billing, and for me on this project, obviously I use it on a limited capacity, so I got to use the free tier, and they even give you $300 of credit up front, which is really nice. You can see that down here. This is in your portal. But again, keep in mind that for storage, long-term storage, streaming inserts, and queries, you have to pay for that, in some way. So at the enterprise level, the one thing I couldn't really test, obviously, is how expensive this would be over time, at scale. So it's great that it can scale up, but I didn't get the experience of how expensive that can actually be. So my experience with it was that it was great. It was free. It didn't exceed any of my limits at all, and it was a success. So then moving forward to ways in which you can interact with data. So you can use the web UI, which is just, again, a web-based platform for you, where you can basically just pop in, say, hey, I want to select data from a data set. You hit compose query, you plug in the dataset ID, and then you can see it's right in here. And then you hit run query, and you're getting your results back. So this is a great simple way that you can use the portal to create data sets. You can also upload data, your own data, and pull them back there. And all of these data sets that you're querying, you can store them as CSVs or JSON tables, or even export them to Google Sheets. So for my demo, in my setup, I used R, and there's a great library called BigQuery. So that's what you need to install these packages that I have listed here in order to kind of get up and running with BigQuery and R. And initially, I planned on using Python and pulling my data from there and then pushing it over to R for visualizations. But because this library is, I had a great experience with it, so I would recommend it. It just seemed a little bit easier to just kind of, do your pulls and then push them into data frames, store them locally, run some, analysis, and create visualizations. So for me, that was a success, and it was fairly straightforward. And we're gonna walk through that together. And then, as I mentioned before, you needed your project ID. You needed to store that as a variable. So make sure you add that in there. And then just to kind of test our connection, there's all kinds of great public data sets, and I went after this Wikipedia data set just because it had copious amounts of data. So I wanted to see if I pull back 500,000 records, what would that look like? How long would that take? It's just a few lines of code here, and you can see that the execution time took about 3 minutes, and now I have this 500,000 records of Wikipedia data stored locally, and that's great. So that was me just kind of testing the connection, making sure that I have a proof of concept. And then I want to walk into my actual demo. I have two of them too. This is MLB data, which is 761,618 rows across 145 variables in the 2016 season. And I was really just wanting to explore, since they had such great data. Again, this is all publicly available. You'll notice in my from statement, that's available to everyone for free. So I was very much interested in trying to learn, are there actual variables here that we can measure scientifically that would demonstrate what's, something that's positively correlated with winning a game. So the home team wins is what I was after. And I imagined that there were, and this is me walking through how I did that. Sure enough, there wasn't a field in the data set that said, home team win indicator. That didn't exist. So I had to create it, and I wrote just a simple case statement that you can see here that just says, hey, when the home final runs are greater than the away final runs, give me a number 1, otherwise give me a 0. And that's important because we're going to use that to measure other variables and how they impact it. Oh, goodness. Sorry about that. So, moving on. When we actually execute the query and analyze our results, again, I'm just pulling from the previous slide, which is my SQL statement, and I'm just pulling that into this query execute statement. And that happened very fast, like instantaneously. Wasn't even able to clock it. And you can see that I've already got the MLB data now stored locally in a data frame. So that's great. I can start running some regressions on it, looking at a linear model. And my first hunch was that, hey, this isn't very scientific, but I want to see if the away team's errors, do they impact home team's winning? Just thinking if the away team made a lot of errors, would that be a possible sign of a home team winning? And sure enough, through running this, the answer is basically no. With an adjusted R-squared of a very, very small number, there's almost no relationship. And continuing on that, I plotted this to see, as errors go up, does that mean that the home team is actually winning? And no, not really at all. So we can kind of continue, again, looking at residuals versus fitted, not seeing much proof in there that the away team's errors is a good predictor for the home team winning a game. So with that, I wanted to look at the actual correlation of all of the variables compared to home team winning. And it was clear that it was home team final hits had a strong correlation with the team wins, and that should be utilized as a predictor in our model. So plugging home team winning indicator with home final hits, I'm now getting stronger R-squareds, 14%, showing you that, yeah, there's an actual relationship there. And it's not the strongest, but at the same time, yes, a relationship does exist between the two. So continuing to plot and explore, getting some better plots in here, looking at box plots. And it's interesting here that, you know, the median amount of hits for the losing team is about 7. For the winning team is 10. But, you know, the upper quartile of teams that lose versus the lower quartile of teams that win, they overlap, right? So if you're getting somewhere between 7 and 9 hits, I can't tell you if you're going to win or lose, right? A medium amount of hits isn't the best predictor. Further, continuing on that, trying to look for outliers, you can see that, you know, even a team that loses over here, you apparently can have 20 hits in a game and you can still lose. And to me, I thought that was very interesting. To be honest, I thought it was wrong. I thought that I must have made a mistake in my data, or I'm pulling it incorrectly, or something of those sorts. So going back to BigQuery, I thought, well, let's just update my query and plug in there where the home final hits is, you know, greater than or equal to 20, and yet the home team's runs is still less than the away team's runs. And sure enough, in 2016, looks like the Padres lost to the Mariners 13-16. So very high scoring game, very much not a normal game. That's why it's an outlier. But it can happen. So that was that data set, which again showed a very interesting relationship between hits and wins. And with the remaining time I have, I wanted to go over another one quickly, which was Chicago crime data. And again, this is another publicly available data set that you can just plug in. It's right here in my from statement. So this data has got 6.3 million records across 22 variables. And my goal here was to analyze the total number of arrests throughout the years and attempt to better understand the type of crimes most common in Chicago over the past 5 years. And again, understanding that it was 6.3 million records, not that I don't doubt that I could pull all those records back and analyze them, but to be honest, I was just looking for the past 5 years to look for recent trends. So I specified that. Still pulled back all the variables, and I was able to pull back about 400,000 records in 3 minutes. So that's pretty solid. And again, now I have that data stored. So, you know, for me, someone who's very conscious of price, if I can pull down my data once and store it locally, you know, I like that. So for R, that seemed to be a quick win. So now I've pulled back 400,000 records, and I want to begin to kind of diving in. So I kind of wanted to aggregate my data, you know, pivot it. And so I went ahead and I did that with this line of code here, and it becomes clear, and I also sorted it, that narcotics, battery, and theft appear to be the top 3 crimes where someone was arrested. I should have made that more clear that I have a flag on here where arrest equals 1. So I'm looking for people that were actually arrested. So again, narcotics, battery, and theft, they are the top 3 for the past 5 years in Chicago. And so that's all very interesting, but again, we want to see a plot of this. We want to see a visual representation. So we go ahead and we bring some, you know, ggplot into the mix. And what I find is very interesting. You know, plot arrest by type in Chicago over the past 5 years. And, you know, it's shaded, and you can see that narcotics kind of dominates the volume here. But in aggregate, the overall trend is that crimes where an arrest was made are going down in the past 5 years. And that's something that, to be honest, was surprising to me, because Chicago has, you know, been kind of politicized a bit and recently as a very unsafe place. And it seems to me that something is going right there in Chicago, in that they're reducing crime. And again, you can still make the case that this is too much crime, but this is a nice trend to see through our data that it is going down. And you could wonder why that is, if it's increased funding or more police force or what have you. But so in conclusion, when looking back at Google BigQuery, it's fast, easy, and dependable. And my big takeaway is that being able to spend more time on insights rather than setup or architecture, and, you know, having a maintenance team for when things break, that's huge. That is tremendous. The barriers to entry are so low, and the ability to plug into BigQuery from an array of tools from any operating system makes BigQuery highly desirable. And the project has afforded me the opportunity to do some quick analysis from public data sets to shine a light on relevant social, political issues, as well as just fun baseball metric insights. So my hope is that Google will continue to add more and more public data sets and continue to offer free trials of their products so that more people can easily research interesting and relevant topics from copious amounts of data. Again, with the big takeaway being that it's incredibly easy. So that's it. Thank you very much for watching.